Hello. So what we're going to look at today are operations on polynomials. We're going to look at addition, subtraction, and multiplication. And so you've probably seen all three of these before in Math 1. We're reviewing them again in Math 2. You'll learn division in Math 3, and then you'll review long division again when we get to Unit 2 in Pre-Calc. So first of all, we're going to look at addition. So we're going to look through a couple of examples. With addition, the main thing to know is essentially you're just combining like terms. So this first example I've got for you, we've got a polynomial 8x plus 5 minus 3x squared plus another polynomial that is 7x squared plus 2x minus 1. Now, just quick review, remember that a number in front of a variable is called a coefficient. And if you've got a number and it doesn't have a variable attached to it, we call that a constant. The variable is what makes it a like term. So I'm going to go through, I'm going to color code, and I'm going to underline all of the terms that have the same variable. So here, if I start with 8x, we'll just start left to right. I'm going to underline it in red, and then I'm going to look in this second polynomial and see if there are any with just an x. Well, here I've got a positive 2x, and so I know eventually those are going to combine. So then the next thing, I've got a plus 5, that's a constant, so I'm looking in the next polynomial and seeing if I have a constant here, and I do, of negative 1. And then finally, I've got a negative 3x squared, underline that in green, and so I'm looking for anything else that has an x squared, and that would be that 7x squared. So if you really like to write out every step and be thorough, you definitely can. And you can go ahead and write the 8x and the 2x together, or you can just use your mental math skills and go ahead and combine them. So since I know that 8x and 2x are together, I'm going to go ahead and write it out for this first example, but we won't do that in the future. And then in the next one, I know I've got a 5 and a negative 1 that go together, and a negative 3x squared and a 7x squared that go together. And so now I'm just going to combine like terms. I'm going to add the coefficients, and then we'll be done. So 8x plus 2x is 10x, 5 minus 1 is 4, and a negative 3x squared plus 7x squared is a positive 4x squared. We do want to practice writing it in descending order, just to help us prepare for factoring later. And so it doesn't change the answer really. Technically, this last step is correct, but we want to get in the habit of making sure everything is descending order. So that would be my final answer there, 4x squared plus 10x plus 4. We'll look at another addition example. So 3x to the 4th, y to the 4th, plus 8x to the 4th, plus 6xy cubed. My first polynomial, my second polynomial is 8x to the 4th minus 8xy cubed minus x to the 4th, y to the 4th. And so we want to do the same thing here. We've got more than one variable, so we've got to look a little bit harder. So here my first variable is x to the 4th, y to the 4th. And so we want to see if there's anything else that has the exact same exponents, the exact same variables in our second set of polynomials. And here we have a negative x to the 4th, y to the 4th. So we know those will combine. And then we'll look here, we've got an 8x to the 4th, and we've got another 8x to the 4th. So since it's addition, we're just looking for like terms really. And then let's see, we'll do purple. We've got a 6xy to the 3rd. And luckily enough, we've got a negative 8xy to the 3rd. And so this one, I'm not going to write out all the way. We're just going to use some mental math. So we're going to put our pinks together. So we'll have 3x to the 4th, y to the 4th, minus x to the 4th, y to the 4th. So again, we're just combining those coefficients. So 3 minus 1 is 2. And we'll have 2x to the 4th, y to the 4th. Then we'll combine the greens. So we've got 8x to the fourth, 8x to the fourth, so together they make 16x to the fourth. And then finally we've got 8xy cubed, we've got a 6xy cubed and a minus 8xy cubed. So 6 minus 8, negative 2xy to the third. And that'll be my final answer. This one doesn't really have a descending order because you've got two variables, so somebody would have to tell you, okay, write it in descending order according to the x or the y. So we'll just leave it like that. I've got one more example for addition, and then we'll move on to subtraction. So this one's a little different. We actually name the functions. So we're going to say let f of x be 4x squared minus 5x plus 2, and let's say that g of x is x minus 2x squared minus 5, and we want to find f of x plus g of x. So it's the exact same process, it's just a little bit different in original question. And so we're going to add f of x and g of x. So first things first, I'm going to write it out just like we did in all the previous examples. And so if I know that f of x is 4x squared minus 5x plus 2, I'll write that first, and then I'll add g of x later. So I'm just writing out the polynomials. So g of x was x minus 2x squared minus 5. And then it looks just like the other two examples. And so we'll go ahead and color coordinate 4x squared minus 2x squared. We've got a minus 5x. We've got an x. And then let's see, we've got a 2 and a negative 5. And so we'll just go ahead and combine them. We'll go ahead and go in descending order. So my highest exponent is an x squared. So we'll combine 4x squared minus 2x squared, which gives me 2x squared. Minus 5x and a positive x, so negative 5 plus 1 is a negative 4. And then 2 plus negative 5 is a negative 3. Already in descending order, good to go. So that's your addition. We'll go ahead and look at subtraction as well. Subtraction is really, really similar to addition, except for one initial step. You want to distribute the negative. So if you were taking notes, distribute the negative should be big and bold, highlighted, underlined, arrows to it. That's the only difference between addition and subtraction. And so you might not know what that means, and so we'll go through that so that you know exactly what it means. So first example, we'll say 7a minus 10b plus 2 minus 3a plus 4b minus 8. And so you'll notice the operation is subtraction now. And so we are going to distribute the negative into the polynomial immediately after. So we're going to make this 3a negative, this 4b negative, and that negative 8 negative. And all that does when we distribute the negative is it changes it to the opposite sign because we're multiplying by negative 1. And so I'm going to write it all the way out just so that we can see it clearly. And you'll notice all the signs change. If you can see it without writing it out, that's fine, but it's much clearer and much more helpful if you do write it out. And from here, all we want to do is combine like terms. So we're looking for 7a, anything else that has an a, got a minus 3a here, a minus 10b, so we're looking for anything with a b, got a minus 4b, and then we've got some constants it looks like that we can combine. So we've got a 2 and an 8. And then our last step, just like addition, nothing new. We already distributed the negative. That's the only new part. We'll just write them all out. So 7a, but I forgot to combine it. So we'll have 7a minus 3a is 4a, negative 10b minus 4b, negative 14b, and then 2 and 8 is 10. So we'll look at another example of subtraction, and we'll say if g of m is 5m cubed minus 3m squared minus 1, and h of m is 2m squared minus 3m cubed minus 4m. Find g of m minus h of m. So again, same question, just different format. It's very mathematical. It's function notation. You'll look more into that later in Math 2, later in Math 3, later in pre-cal, later in really any math that you take. So we're going to go ahead and write it out. So g of m comes first, so we'll recopy all of that. We're basically just substituting it in. We know it's subtraction, and I put both of them in parentheses just so that I remember that, hey, eventually I'm going to have to distribute the negative because we are subtracting. So that's exactly what I'm going to do next. Take that negative, distribute it into every single term, and what that does is changes the sign. And so we'll write it all out again. Make sure we don't make any mistakes. And then we'll just combine like terms. So we've got a 5m cubed and a 3m cubed, a negative 3m squared and a negative 2m squared. And we've got a negative 1. And we don't have any other constants, so that's the only thing that doesn't have a like term, so we'll just have to bring it down. And then we've got this other thing over here, this 4m, that also doesn't have any like terms. So when we combine, we just want to make sure to bring them down. And we'll go ahead and do it in descending order, so it'll save us a step. So the highest exponent we've got is that m to the third, so we'll do 5m plus 3m to the third, which gives us 8m to the third. Descending order says something squared comes next, so negative 3m squared minus 2m squared gives me a minus 5m squared. And I have the negative 1 and 4m next. Well, in descending order, 4m would come next, and then that minus 1. So those are two examples for subtraction. It's so similar to addition, I don't know that we need a third one, but you can always, well, we'll do one more because we'll combine addition and subtraction. So I take that one. All right, so last example, we'll combine those operations and then we'll move on to multiplication. So we've got 5x to the fourth plus 3x to the third plus 10x squared plus 2x cubed minus 3x to the fourth minus 8x to the third minus 4x squared plus 7. So if you are taking notes, I would suggest you to pause the video right now and see if you can do this one by yourself. It combines addition and subtraction, but it's all combining like terms. And so since we've got subtraction, I am going to rewrite it to make sure I have the distributed negative in there. And so it is a lot of writing, but that's okay. And then I'm going to get rid of the parentheses. Beyond distributing the negative, they don't really serve a purpose other than telling us that we have multiple polynomials. So I distributed the negative and all of their signs change. And then we're going to combine like terms. So 5x to the fourth, I've got a minus 3x to the fourth. Looks like that's it. 3x to the third, 2x to the third, minus 8x to the third. So we have three terms to combine. Let's see, we've got a 10x squared, 4x squared, and then here at the very end, we've got a minus 7. And it doesn't combine with anything, it's just kind of a loner. All right, and then we'll write in descending order. So 5x to the fourth minus 3x to the fourth, it gives me 2x to the fourth. 3x to the third minus 8x to the third is a minus 5x to the third. So remember, the variable and the exponent is what is making it the like term. We've got 10x squared and 4x squared. And then we don't have any linear terms, so we don't have anything with just an x. So then we'll just bring that 7 down. And as you're going through it, if it's helpful, you can mark through all of the ones that you've combined so you know exactly what's left, but that's just up to you. So we've got multiplication left. I've got a couple of examples there, and then you'll know all three operations for polynomials. So let's look at multiplication. Now, the super simple version is basically distributing everything to everything. And you could also look at multiplying as reverse factoring. You could also look at multiplying as using your product rule and the exponent rules. I personally like multiplying. It's very pretty and easy, and you get to draw a bunch of lines everywhere. So here, let's look at an example. So this first example is just purely distribution. So we'll have 2x to the fourth y multiplied by a polynomial of 3 terms. So we've got 4x squared y squared plus 3xy plus 9. And just like we distributed the negative, we want to multiply this term in front to every single term inside the parentheses. So here the parentheses indicate that we need distribution. So we'll go ahead and go here. And you want to multiply everything by everything. And your bases is what's important. So the coefficients of 2 and 4 are bases that are similar. Your base of x is what's similar, and that's what you'll multiply, as well as your y's in that first term. So we're going to multiply 2 times 4, which is 8. X to the fourth times x squared is where we use that exponent product rule. So same base, add exponents. So we've got x to the fourth, x squared. So multiply your x's and then add exponents. So 4 plus 2 is 6. And then y times y squared. So this y doesn't have an exponent visible, but because we are very smart, we know that there's a 1 there and it doesn't change the value at all. So when we multiply those y's, we'll have the base of y, and 1 plus 2 is 3. Then we'll distribute it to our next term. So we'll have 2 times 3, which is 6. X to the fourth times x. Same thing here. We understand that there's a 1 there and it doesn't change the value. So we'll have 4 plus 1, which is 5. And y to the first, 1 plus 1 is 2. And then this last one is easy because it doesn't have any variables. So we just have to multiply that 2 times the 9 and then attach that x to the fourth y. Done. Super straightforward. So we'll have another example with distribution. So we'll have 4x squared times 4x to the third minus 2x minus 8. And then we're going to add a second set, adding a little more complexity. So we've got 2 sets of parentheses, which means we're going to distribute some terms twice. So I'm going to go ahead and distribute it with my little arrows in that first term. So we'll multiply 4x squared times 4x to the third, 16. 4 times 4 is 16. X squared times x to the third, same base, add exponents. So we'll have x to the 2 plus 3, which is 5. And then we'll have 4x squared times a negative 2x. So 4 times negative 2 is a negative 8. X squared times x. Remember, there's an understood 1 exponent. So base x, 2 plus 1 is 3. 4x squared times a negative 8. So no variables, so we're just multiplying the coefficients. 4 times negative 8 is a negative 32 x squared. And then we've come to our second set of polynomials. So we need to distribute again. We want to distribute that negative with the 2x. So we're kind of killing 2 birds with 1 stone. Distributing the negative and distributing that 2x. So we'll have negative 2x times x squared, negative 2x cubed, assuming we know that there's a 1 there. And then a negative 2x times a negative 3x gives us a positive 6x squared. And so you have already multiplied all the way, and that's a really great start, but you may notice that there are some like terms in there. So now we have to go back to our other operations and combine like terms since we've got some. So nothing combines with 16x to the fifth. but negative 8x to the third has a negative 2x to the third later. And this negative 32x squared and this 6x squared are also like terms. So one more step, 16x to the fifth. My x cubes combine, so negative 8 and negative 2 gives me a negative 10. And my negative 32x squared and my positive 6x squared give me a negative 26x squared. And that is my final answer. So beyond distributing, we also have a different kind of polynomial multiplication. And so it looks like this as an initial expression, 2x minus 2. And so there are really two ways that you can do this. You can do the FOIL method, which is drawing all your lines everywhere, and that's where the distributing everything to everything comes in handy. Or you can draw a box off to the side. It's very visual. I really like it. And you can multiply it that way. And so that's what we're going to do for this first example, just so you can see it. So since I've got a binomial, means it's got two terms in both sets of parentheses, I'm going to draw a box that is 2 by 2, and each term gets its own row and column. When you do that, just make sure that 4x plus 5 go together, and the 2x and the minus 2 go together. You don't want to split those into different rows and different columns. And then we're going to multiply. So where the rows and columns intersect is where you're going to multiply. So we'll have 4x times 2x, which is 8x squared, 5 times 2x, 10x, 4x times negative 2, negative 8x, 5 times negative 2, negative 10. And what's really cool about this box method is that if you have like terms, they'll be diagonal from each other. And so then when you write it out, all you have to do is remember to combine that diagonal. So 10x minus 8x is a 2x. And we'll bring down everything else. Already in descending order. Pretty cool. So we'll look over here at the next example. So we've got x minus 8y squared, which is kind of weird looking. We haven't really seen that before, and you might think, hey, I'll just distribute this 2 in there. Well, no, you would be wrong, and that's okay. It's a common mistake. But what we do need to remember is that this is just saying x minus 8y is being multiplied by itself. And so now it looks just like the first example. And so we'll go ahead and draw a box here as well. And then we'll go ahead and multiply it out. Most of you are pretty comfortable with this. Oh, I drew my box really small. So I'm kind of going pretty quick. And then it's pretty cool because your diagonals are like terms of negative 8xy. And so when we write that out, we'll have an x squared minus 16xy plus 64y squared. Just be careful with your operations. So we'll look at, let's see, 2 more. We'll do one with the FOIL method. And if you really like the box, then you can just ignore this part of the video. But I do want to show you that it exists. And so we've got 3x minus 4 times an x plus 7. And so the FOIL method, literally spelled FOIL, just means you multiply your first terms together, your outside terms, your inside terms, and your last terms. So your first would be the first one you come to, so 3x and x. And this is where you get all those funny lines. So 3x times x is your first. Your outside is the very outside. So you'll have 3x times 7. And then your inside is where your parentheses are rubbing up against each other. So you've got a negative 4 and an x. And then your last terms in each binomial. So negative 4 and 7. So you got all these funny lines instead of a box. So it's just a personal preference up to you. And then you'll just combine your like terms. When you do the FOIL method, it'll be the inside, or these two right here. So they are nicely together for you. All right. And then I've got one more. It's a challenge problem. You can multiply polynomials of any number of terms. So you could have a 2 by 2, a 2 by 4, a 2 by 3, 3 by 3, 4 by 4, and it could go on forever and ever and ever. And so I would suggest to make sure that you multiply everything by everything just to draw the box. And so this challenge problem is a 3 by 3. So negative 3x squared minus 2xy minus 8y squared times 8x squared plus 4xy plus y squared. So you won't see a lot of these a whole lot. They're not really super useful. And there's not really a whole lot of real world applications where you've got boxes like, or you've got polynomials like this, where you're multiplying them. So it's purely just for mathematical practice. So we do have a 3 by 3, so I'm going to draw a 3 by 3 box, hopefully giving myself enough room, because I did not the last time. And then I'm going to draw each of my terms in here. So if you want to pause the video and see if you can multiply it by yourself, that's a good idea. If not, we'll do it together. So remember, we're going to multiply each column by the row, and where they intersect is what we're going to multiply. So first things first, negative 3x squared times 8x squared. Negative 2xy times 8x squared. So negative 16x to the third y. Remember, this x hasn't understood 1 as an exponent. Negative 8y squared times 8x squared. So negative 64 x squared y squared. Doesn't really matter the order, your x or your y. And then we'll do the next rows. So negative 3x squared and 4xy. So we'll have a negative 12 x to the third y. Negative 2xy times 4xy, negative 8x squared y squared. Negative 8y squared and 4xy, let's see, negative 32xy cubed. Negative 3x squared times y squared. No like terms there, just combine them. Negative 2xy times y squared. Negative 8y squared times y squared, and we finish the box. So with the box, remember that if you have like terms, they will be diagonal from each other. So we've got a couple of diagonals in there. And we'll combine like terms in our last step. So we'll have a negative 24x squared. Like terms here, negative 16 and negative 12 is a negative 28. And we'll just keep the x cubed y, that's what makes them alike. Negative 64, negative 8, and negative 3. So let's see. Negative 75, x squared, y squared. And then we've got a negative 32 and a negative 2, so negative 34, xy cubed. I'm almost going to run out of room. And then we've got that minus 8y to the fourth that doesn't combine with anything. So I'll just squeeze it in below. So those are your 3 operations. Good to go.